The provided information does not contain any electrical details to discuss. Therefore, a meaningful audio narration about electrical topics cannot be created from the source. Electrical codes, standards, and practices are extremely important to understand when dealing with any electrical work. These standards exist to ensure safety and proper functionality of electrical systems. Without specific content, I can only offer general electrical safety advice. Always to energize circuits before working on them. Use properly rated tools and equipment. Follow the National Electrical Code, or NEC, and any local codes. If you are not a qualified electrician, do not attempt electrical work. Contact a licensed professional. Electricity can be dangerous and potentially fatal if not handled correctly. Never work in wet conditions. Always wear appropriate personal protective equipment, or PPE, such as safety glasses and insulated gloves. Understand the voltage levels you are working with. Be aware of potential hazards like arc flash and shock. Inspect your equipment regularly for damage. Replace any damaged cords or plugs immediately. Use ground fault circuit interrupters, or GFCIs, in wet locations and where required by code. Test GFCIs monthly to ensure they are working properly. Do not overload circuits. Use appropriately sized conductors for the load. Use correctly sized overcurrent protection devices, such as circuit breakers and fuses. Ensure all electrical boxes are properly grounded. Use appropriate wiring methods for the environment. Protect wiring from physical damage. Keep electrical panels clean and free of obstructions. Label circuits clearly. Document any changes to the electrical system. Have a qualified electrician inspect your electrical system periodically. Be aware of the location of emergency shut-off switches. Know how to respond in case of an electrical emergency. Use lockout/tagout procedures when working on electrical equipment. Control of hazardous energy, or LOTO, is critical for safety when working on electrical systems. Before working on any electrical equipment, identify all sources of electrical energy. Disconnect all sources of electrical energy. Verify that the equipment is de-energized. Apply lockout devices to prevent the equipment from being re-energized. Tag the lockout devices with information about who performed the lockout and why. Only the person who performed the lockout should remove the lockout device. Follow a documented lockout/tagout procedure. Train all employees on lockout/tagout procedures. Conduct periodic audits of lockout/tagout procedures. When working with electricity, it is important to understand basic electrical concepts. Voltage is the electrical potential difference between 2 points. Current is the flow of electrical charge. Resistance is the opposition to the flow of electrical charge. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. Power is the rate at which electrical energy is transferred. Power is measured in watts. Watts equals volts times amps. Electrical circuits can be series, parallel, or a combination of both. In a series circuit, the current is the same through all components. In a parallel circuit, the voltage is the same across all components. Conductors are materials that allow electricity to flow easily. Insulators are materials that resist the flow of electricity. Copper and aluminum are common conductors. Rubber and plastic are common insulators. The National Electrical Code, or NEC, is a set of standards for the safe installation of electrical wiring and equipment. The NEC is updated every 3 years. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Electrical permits are required for many electrical installations. Electrical inspections are required to ensure that electrical installations comply with the NEC and local codes. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip overcurrent protection devices. Grounding also helps to reduce the risk of electric shock. Grounding electrodes must be properly sized and installed. Grounding conductors must be properly sized and connected. Bonding is the process of connecting all metal parts of an electrical system together to create a low-impedance path for fault current. Bonding helps to reduce the risk of electric shock. Bonding conductors must be properly sized and connected. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Circuit breakers and fuses must be properly sized for the circuit they are protecting. Circuit breakers and fuses must be properly installed and maintained. Arc flash is a dangerous electrical explosion that can occur when there is a short circuit in an electrical system. Arc flash can cause serious burns, injuries, and even death. Arc flash hazard assessments are required to determine the potential arc flash hazard at a particular location. Arc flash personal protective equipment, or PPE, is required to protect workers from arc flash hazards. Electrical safety training is essential for all workers who work with or around electricity. Electrical safety training should cover topics such as electrical hazards, safe work practices, and the use of personal protective equipment. The NEC has several tables for conductor ampacity. Ampacity refers to the current carrying capacity of a conductor in amps. Table 310.15b16 is commonly used to determine the ampacity of conductors based on their insulation type and temperature rating. Correction factors may need to be applied to the ampacity based on the ambient temperature and the number of conductors in a raceway. The size of the conductor must be adequate for the load it will carry. Undersized conductors can overheat and cause a fire. The NEC also has tables for conduit fill. Conduit fill refers to the percentage of space inside a conduit that is occupied by conductors. The NEC limits the amount of conduit fill to prevent overheating of conductors. Different types of conduits have different fill requirements. Proper wiring methods are essential for electrical safety. Wiring methods refer to the way that conductors are installed and protected. Common wiring methods include conduit, cable, and surface raceway. The NEC specifies the requirements for each wiring method. Use the appropriate wiring method for the environment. Protect wiring from physical damage. Support wiring properly. Make sure all electrical connections are tight and secure. Loose connections can cause overheating and arcing. Use appropriate connectors for the type of conductor and equipment being connected. Torque connections to the manufacturer's specifications. Label all electrical panels and circuits clearly. Labeling helps to prevent confusion and makes it easier to troubleshoot problems. Use permanent labels that are resistant to fading and weathering. Document any changes to the electrical system. Documentation helps to keep track of changes and makes it easier to maintain the system. Keep a record of all electrical inspections and repairs. Regular maintenance is essential for electrical safety. Inspect electrical equipment regularly for damage. Replace any damaged parts immediately. Clean electrical equipment regularly to remove dust and debris. Test ground fault circuit interrupters, or GFCIs, monthly. Calibrate electrical testing equipment regularly. Follow the manufacturer's recommendations for maintenance. When troubleshooting electrical problems, start by checking the basics. Check the power source. Check the circuit breakers and fuses. Check the wiring connections. Use a multimeter to measure voltage, current, and resistance. Follow a systematic approach to troubleshooting. If you are not sure how to troubleshoot an electrical problem, contact a qualified electrician. Electrical testing equipment is used to measure electrical parameters such as voltage, current, resistance, and continuity. Common electrical testing equipment includes multimeters, clamp meters, and insulation testers. Use electrical testing equipment safely and properly. Follow the manufacturer's instructions. Wear appropriate personal protective equipment, or PPE. Be aware of the potential hazards. Electrical systems are complex and require specialized knowledge. If you are not a qualified electrician, do not attempt electrical work. Contact a licensed professional. Electricity can be dangerous and potentially fatal if not handled correctly. The information provided here is for general knowledge only and should not be considered a substitute for professional advice. Always consult with a qualified electrician for any electrical work. Remember to always prioritize safety when working with electricity.